Bismillahirrahmanirrahim. Assalamu alaikum, student.
عليكم السلام ورحمة الله وبركاته.
وعليكم السلام.
عليكم السلام.
So last time we were studying this chapter number 4. So in chapter number 4, you remember that its title was motion in two dimension. Motion in two dimension. So in motion in two dimension, what we were studying actually the projectile motion. Projectile motion. So last time we have discussed a lot of things about this projectile motion, and you remember that this is actually, I want to discuss the summary of this projectile motion. So this is the motion of a projectile, and this is the initial velocity, and at the highest point, the final vertical velocity is 0, and the horizontal velocity remains constant everywhere in its path. And this is the horizontal distance or the range, horizontal range. And this is the maximum height. So last time we have used some kinematic equations, that is Vix is equal to Vf of x is equal to Vi cos of theta. And A of x is equal to 0. Then we have used that Vi of y is equal to Vi sine of theta, and Vf of y is equal to Vi of y minus gt. So Vi of y is Vi sine of theta, and Ay is equal to minus g. Then we have used some other formulas about this x is equal to Vi cos of theta into t, and y is equal to Vi y into t minus 1 over 2 gt square. So this is actually delta y. And we use the formulas of the range Vi square sine 2 theta over g. Then we use the formula for the maximum height, that it is Vi square sine square theta over 2g. And then time of flight 2Vi sine of theta over g. And then the last formula was the equation of the trajectory or the path, and that is y is equal to x tan theta minus gx square over 2Vi square cos of square theta, like this one. So these are the formulas which we have applied to solve our problems. But the most important thing in solving the problems of this projectile motion, last time I have solved some basic problems, the easy problems. But here I want to discuss the situations in the projectile motion. Situation in projectile motion. So situation is what? There are different kinds of situations in projectile motion exist. The problems can come at, from that different situations. Okay, let's see. The first situation is this one. If this is a tower or a building or any vertical height, so the ball or the object is throwing horizontally. This is horizontal. It is throwing horizontally. Then the ball will come like this one. And this is y and this is x. You can find here the time. You can find here the speed or the velocity at this point. One situation is this one. The other situation is if this is the height and it is not throwing horizontally, it is throwing above the horizontal. No, I'm saying above the horizontal. So above horizontal means this is horizontal and this is above horizontal. And it is going like this one and then come back. So this is y, this is x, and this is the time you can find, or the speed or the velocity you can find. But if it is above the horizontal, It means this this velocity has two components, one along x-axis and one along y-axis. One situation is this one. The other situation is if this is a barrier or a fence or any building, and you throw a ball from here and it is clear this building like this one, and its velocity, its angle, this is its height, and this distance is given like this one, and how to control this type of problem. This is another situation. The other situation is this one, that if you throw a ball and here is another building and its height is some height, and this is the vertical, and it comes from like this one and coming here. Okay. After this, we have another situation, and that is if this is a pole, and this pole we have a basket of the basketball. So you can throw a ball here and put it here in the basket. So what is the initial velocity? What is the angle? And what is this basket height? This is also important. And how much is the distance from here? This is one situation. This is the barrier, and this is the horizontal distance, and this is the center point. And if any ball, any bullet is falling, throwing in this direction, in front of the center, and then it is going like this one, how much distance it will come here? This is another situation. So all these situations are very important to solve the problems. So you must remember the problem is related with which situation. And the other thing you should remember that the initial velocity mean Vi, and sometimes it is written that the ball is throwing horizontal with horizontal velocity. So with horizontal velocity mean what? Horizontal velocity mean it is Vix or it is Vf of x, because it remains constant, and this is equal to Vi cos of theta. This is horizontal velocity. And sometimes the problem is related that the ball is throwing with the below the horizontal. So below horizontal mean this is your horizontal, and below horizontal mean it is like this one. So this is the angle of below. So in below horizontal, you have this Vi of x, and this is your Viy. So Viy here is in the downward direction. So that's why its answer is negative in vector form. So vector form Vix, you know that it is equal to Vix. I am putting here vector, and this is I unit vector, and Viy is equal to, if this is Viy, then it is J unit vector. If it is downward, then we will put here negative sign. So after controlling all these situations, now we are coming towards our problems. So how to solve the problems? Controlling these situations. Okay. So any question?
No, Doctor. So far, so good.
Okay. So after this, I'm sharing the questions. The questions are here. Okay, let's see the questions. Okay, now you can see the problems. So the problem is, all problems are about projectile motion. So today I will solve the problems of projectile, and maybe some more problems I will solve in the next lecture. Okay. So after next lecture, then we will start the last article of this chapter, uniform circular motion. Okay, let's see the problem. In this problem, you can see that the initial speed of a cannonball is 0.2 kilometer per second. This is the initial speed. So initial speed, initial velocity means this is VI. This is not VIX. So this is VI. So VI is 0.20 kilometer per second. So you will convert it into meter per second. So the answer will be 200 meter per second. This is problem here. Just okay. So this is 200 meter per second. This is VI. Up to now, I write like this one. If the ball is to strike a target that is at a horizontal distance of 3 kilometer, so it means the X value is 3 kilometer. It means it is 3000 meter. From the cannon, what is the minimum time of flight for the ball? So we have to find the time of flight. So time of flight formula is, you remember that this is 2vi sine of theta over g. This is the formula. But to apply this formula, we know we have a value of vi, but we don't know the value of theta. So to find the value of theta, what we have to do? We have to apply some another formula. So to some another formula is R is equal to VI square sine of 2 theta over G. So R is what? R is actually this X. This is horizontal range. And this is 3000 is equal to VI square and sine of 2 theta over G. So you can solve this one by using this value. This is VI square. VI is 200. So this is 200 square into sine of 2 theta over 9.8. Now simplify this one. Sine of 2 theta is equal to 3000 multiplied by 9.8 divided by 200 square. So when you solve this one, you will get the answer of 0.735. I already calculated this one. So this is sine 2 theta is equal to this one, and 2 theta is equal to sine inverse 0.735. So when you solve this one, your answer will be 47.30. This is 2 theta. And what will be the theta value? Theta value will be 47.30 divided by 2, and this is equal to 23.65. Now we have theta value. We need time of flight. So what we will do? 2 into 200 multiply by sine of 23.65, 23 point here, 65 divided by G, 9.8. So when we solve this one, we will get the answer of 16.37 second. This is the time of flight. So here the answer is 16. So this is our answer. So in this way, you can solve this problem. So in this problem, you have to apply two formulas to solve this one. Okay, after this, see this problem. In this problem, a ball is thrown horizontally. Now the horizontally it is thrown. Okay, so it means from the top of building 0.10 kilometer high. So this value is given 0.1 kilometer, and this is equal to 100 meter. We must convert it into meter. One thing, the ball strikes the ground at a point 65 meter horizontally. So this is horizontally. So it means the ball is coming like this one, and its horizontal velocity is this one. 65 meter is this one, and this is equal to x from and below the point of release. Mean from where it is released from here to here, the value is 65 meter. What is the speed of the ball just before it strikes the ground? So he's asking about the speed of the ball. So remember, the speed or the velocity is here, is the combination of horizontal and vertical components. So what we have to do, we have to find the speed, that Vf of x square plus Vf of y square and under root. So we need this value. So to find this value, first we will find the time here. So to find the time, what we will do, we will apply the formula that y is equal to Vi y into t minus 1 over 2 gt square. Actually, this is delta y. So delta y mean here the y final is 0. Here the y initial is 100. This is actually initial is 100. So what you will do, that delta yf minus yi is equal to viy into t minus 1 over 2 gt square. You will apply in this form. So 0 minus 100 is equal to viy. So from the highest position, when the ball is coming down, then v of y is equal to 0. So this vector will be 0 minus 1 over 2 into 9.8 into t square. So you can solve it, and t square will be 200 divided by 9.8. So this implies that t is equal to 200 divided by 9.8 under root, and the answer is 4.51 second. This is second. Okay. Now we have a time value. We want to find the v of f of x and v f of y. So v f of y will be what? V f of y will be V I of y minus gt. V f of y, V I of y is 0 minus g 9.8 into 4.51. So multiply this one, you will get the answer of 44.1 with negative sign. Okay. Now find the Vf of x. So here Vf f of x is not given. So what you will do, you will apply the formula x is equal to Vf of x into t. So x is 65. Vf of x into t. T is 4.51. So Vf of x is equal to 65 over 4.51. So when you solve this one, you will get the answer, which I have calculated already, 14.41 meter per second. Okay. So this is also meter per second. Now you can find the value of V. V is what? Vf of x square, mean 14.41 square plus minus 44.1 square or 44.1 square, the value will be same. So under root and solve this one, the answer is 46.39 meter per second. So in this way, you can find the value of this V. So in the picture, you can say, see that this one is Vf of x here, and this is your Vf of y in the downward. So that's why it is negative. So you need actually this value, this value. So to find this value, what you will do, Vf of x square plus Vf of y square and under root. Okay. After this, so this is a problem in the previous class. It creates some problem for me. So I left this problem. We will solve this problem in the next lecture. First, I want to clear the statement. Here the statement has some problem. Okay, let's see this problem. So in this problem, you can see that a rock is projected from the edge of the top of a building with an initial velocity. So this is the building. This is a building, and this is the horizontal ground. and a rock is projected from here with an angle of 53 with initial velocity 12.2. Here Vi is given. This is not Vi of x or Vi of y. This is Vi, meter per second, and theta angle is 53 degree. The rock strikes the ground at a horizontal distance of 25 meters from the base of the building, from here to here. So how the rock is projected? It is like this one. So it is going up and then coming down. So this is the horizontal and this is the vertical. So here this is horizontal and this is vertical. And this is Vi. Now you can find the Vi x. This is Vi cos of 53. And Vi is what? 12.2 cos of 53. And similarly, you can find VIY. This is 12.2 sine of 53. So in this way, you can find these values. Okay, let's see. The horizontal distance is 25 meter. So this X is 25 meter. It is given. The question is what? Assume that the ground is level and that side of a building is vertical. How tall the building is? So you need this Y. How tall? So to find this one, we apply the same formula. Delta Y is equal to VI Y into T minus 1 over 2 GT square. Okay. So to find this one, what we will do? So delta Y mean this is initial and this is final. So final is 0 and initial is this one. So 0 minus Y is equal to VIY. So VIY is VI sine of theta. Here we will not put that VIY is 0. No, because it is going up and coming down. We are not taking from this position to this. We are taking from here. So that's why you must put this value into T minus 1 over 2 GT square. This is our equation. Now to solve this equation, putting the values, minus Y is equal to VI sine of theta, mean 12.2 into sine of 53 into T. So T, we don't know the T value. So we will find the T value, minus 1 over 2, 9.8 into T square. So to find the T value, what we will do? We will apply to find T. So what we will do? Here X is 25 meter. It is given. So X is equal to VI cos of theta into T. We apply this formula because already we know this value. So X is 25 is equal to VI 12.2 into cos of 53 into T. So in this way, you can find the value of T. So T value is, if you solve this one, it will be 3.4 second. So you have this answer and you have this equation. And what we will do? We will put this value 12.2 into sine of 53 into 3.4 minus 1 over 2 into 9.8 into 3.4 whole square. So when you solve this one, your answer will be Y is equal to 23.6 meter. So this will be your answer. So here in this question, you can see the ball is projected from the top of the building. It is going up and then coming down. It is not like this one. Okay, so you should control this thing. Okay, after this, again see this problem. A projectile is thrown from the top of a building with an initial velocity of 30 meter per second in horizontal direction. So here the direction is horizontal. So what you will do? This is the top of the building. It is projecting in horizontal direction. It is not going like this one. So it is in this direction. It means this is your Vix or Vf of x because it remains constant. So this is 30 meter per second. One thing. If the top of the building is 30 meter, So this top is given, it is 30 meter. Okay. How fast will the projectile be moving just before it strikes the ground? So it means the projectile will fall down like this one. Okay. If the top of the building is 30 meter from the ground, how fast? So we need the Vf of x, and this is your Vf of x. This is your Vf of y, and this is your V. So to find this V, what we will do? We will find the Vf of y. So to find the Vf of y, we need the time. So first we will find the time, or you can apply the formula that Vf of y is equal to Vi of y minus Gt. So Vi of y is here 0. Now it is coming from the upward, 0. So Vf of y is equal to minus Gt. So we don't know t. So what we will do, we will find the t. Again, apply the formula delta y is equal to Vi of y into t minus 1 over 2 gt square. So delta y mean here y final is 0. So 0 minus 30 is equal to Vi of y is 0. So this will be 0 minus 1 over 2 into 9.8 into t square. Now you can solve this one for the time. So the time value is 2.47. So we have time value. We have Vf of y. So here you can put the value Vf of y is minus 9.8 into 2.47. So when you multiply this one, you will get minus 24.20 meter per second. So this is your Vf of y. But what is your Vf of x? It is 30. So why it is negative? So because it is downward. That's why it is negative. So we have this value minus 24.20, and this value already given, it is 30. So this is 30. Okay, now you need this one. To find this one, what you will do? So 30 square plus minus 24.20 square and under root. So when you solve this one, you will get the answer 38.56 like this. This is approximately 39 meter per second. So this is your answer. Okay. After this, we have another problem. So in this problem, you can see a tennis player standing 12.6 meter from the net. If this is a net, okay, and he is standing 12.6 meter from the net, hits the ball at 3 degree. So he hits the ball at 3 degree. From here, angle is 3 degree. One thing, above the horizontal. Above horizontal mean like this one. If below horizontal, then angle will be down. So to clear the net, the ball must rise at least. So the ball must rise at least 0.33 meter. So it means the ball is rising 0.33 meter. If the ball just clears the net at the apex of its trajectory. So this is the trajectory. Okay. How fast was the ball moving when it left the racket? So you have to find this Vi value. How fast was the ball moving when it left the racket? So when it will left the racket, we should know the Vi value. So here you can see that we have different formulas, but height maximum formula we cannot apply, and range formula we cannot apply. So this is the trajectory. So for trajectory, we will use this formula x tan theta minus gx square over 2 vi square cos square theta. So we need vi. So here y is this value 0.33, x is 12.6 into tan of 3 degree minus 9.8 into 12.6 whole square divided by 2 into vi square and cos square into 3 degree. So when you solve this one, what will be the answer? Here will be 0.33, and when you solve this one, the answer will be 0.66 minus, and when you solve this one, this answer will be 780.8 over VI square. So after solving this one, what you will get? So 780.8 divided by VI square is equal to 0.66 minus 0.33. So you will get 0.33. So after this, you can solve it. This is VI square over 780.0. I just reverse this one, invert it. So this is 1 over 0.33. Now it will go here. So when it will go here, the answer will be what? I'm writing the answer here, that VI square is 780.08 divided by 0.33, and you can take the under root, and VI value will be 48.6 meter per second. You can check it with the calculator. So this is 48.6 meter. This is the answer. So here in this question, you should apply the trajectory equation. Otherwise, your answer will not come like this one. Okay. After this, a rifle is aimed horizontally at the center of a large target 60 meter away. So this is the target and its center is here. This is the center. This is the center line. And its center is away and its value is 60 meter. This is X value. Here it is written. With an initial speed, the initial speed of the bullet is 246 meter. Surely it is fired like this one. And this is actually the horizontal velocity, 240 meter per second. So what is the distance from the center of the target to the point where the bullet strikes the target? So the bullet is going like this one. Okay. So we need this Y distance from this center. To find this Y, what we will do? Again, we will apply the formula. Y is equal to what? VIY into T minus 1 over 2 GT square. So VIY from here is 0. So minus 1 over 2 GT square. And this is equal to minus Y, because final and initial, when you solve this one, it will be minus. Now to find the time, we need actually the time. So Y is equal to 1 over 2 GT square. To find the time, X value is 60 meter. Okay. And VIX is what? This is actually your VIX. This is 240. Okay. And find the time. So X is equal to VIX into T. And this is 60. VIX is 240 into T. So when you solve this one for the time, X is 60. So time is equal to 60 over 240. So this is 0.25 second. Now you can put this value here, 9.8 into 0.25 square. So when you solve this one, you will get 0.306 meter. So this is the answer. So in this way, you can solve this problem. So up to now, we have finished these problems, and maybe we will solve 2-3 problems more in the next lecture. And then we will start this in the next article, the circular motion, uniform circular motion. Okay, if you have any question, you can ask me. Otherwise, stopping.
Doctor,
Yes.
can I ask a question?
Yes.
How many chapters do we have to study for midterm exam?
So I have asked the old course coordinator, Dr. Abu Bakr. He said that maybe your midterm exam will be not in October, maybe in November, and only one midterm exam. Maybe one midterm exam. So if it is one midterm exam, then surely the chapters will be at least six, at least six chapters or seven maybe. Okay.
Okay, thank you.
Okay, so if you don't have any question, so see you in the next lecture.
Thank you, Doctor.
Okay, Assalamu alaikum.